I'll take a look at another proof about congruences. So let n be a natural number, a and b are integers. Assume that a is congruent to b mod n. Show that n divides a if and only if n divides b. Okay, so when it comes to this proof that we're going to look at, first off, we have some basic assumptions, right? So we can just work with these. So we can say now let n be a natural number, a and b our integers, and we can now say assume a is congruent to b mod n. Now, where we're trying to go is we're trying to prove this if and only if statement. So remember, to prove an if and only if statement, you have to prove both directions of the proof. But how I'm structuring my proof, notice, is I have these assumptions that are going to be true for both directions. So I can state these first before I start to prove one of the two directions. But before I get to proving those directions, I could, again, try to continue to unpack everything that's going to be true for both directions. So here, I'm going to use the definition to then figure out what does this really imply. So assume a is congruent to b mod n. This implies that there exists a k in the integers such that a minus b is equal to kn. So there exists an integer k where this is true. Okay, so this is just the definition of congruences. Now we can go ahead and start proving the directions. So in this direction, we're going to assume that n divides a. All right, now again, now we use our definitions that this implies there exists some j which is in the integers such that n times j is equal to a. So again, there exists an integer in z. Now notice, I'm using some of the shorthand. So this exists, we saw this from the quantifier statements, right? This backwards e says that there exists a j. If I said for all j, I could use the brief notation of the upside down a. Okay, so now that we have this statement that n times j is equal to a, I can now use this with this statement up here because I know this is true. So since a minus b is equal to kn, this implies that nj minus b is equal to kn. But then this implies, by simply moving some of our variables around, I could say add the b over. So I can add the b and subtract this over. So I'd have nj minus kn is equal to b, which then implies that j minus k times n is equal to b. So just do some algebraic manipulation, get it to this form. Our goal is to try to use the definition that n divides b. Remember, definition of divides is that there's an integer that you multiply n by to get b. So does there exist an integer you multiply n by to get b? Well, yes, that happens to be j minus k. So we just have to state that. So then since j and k are integers, we see j minus k is also in the set of integers. So then by definition, n divides b. Now, some of you might be thinking, wait, do I have to say, though, that since j and k are integers and the difference of integers is also an integer? Technically, you could say that, but we're kind of now getting to the level of proofs in this class where we're dealing with a little bit more interesting definitions. We don't really need to be stating those basic things anymore. So I won't be taking off for those. Feel free to keep just, saying things that are true and things that are necessary to get to the conclusion. You might not need to state all of the middle steps. And if there are things like that, feel free to ask questions on that. But this proves one of our directions of our proof. So now we can prove the opposite direction. But as you would expect, this is going to be very similar to this forward direction, where now we're going to assume that n divides b, and then there exists some integer, say m, in the integers, such that m or n times m is equal to b. So then we'd say, since a minus b is equal to kn, this implies that a minus n times m is equal to kn, which then implies that a is equal to kn plus nm, which then implies that a is equal to k plus m times n. And then we simply finish this off by saying, since k and m are in Z, we see k plus m is also in Z, hence n divides a. So basically, the heart of the proof is having you be able to just use this definition of congruence and then making sure that you have the proper definition of divides and remembering how to do the if and only if proof. But once you have this first part, the second part here is pretty much the same exact thing.